This is Unit 4, Investigation 5, Lessons 1 and 2. We're starting off with the entry ticket together. We're working with exponential functions again. The generic form of any exponential is y is equal to a times b to the x power. A is that initial value of the function when x is equal to 0. So if you actually look down at this table right below here, I've already boxed in yellow. When x is 0, y is 2. So that's going to be our a value. So that's actually our first question. So that's actually our first question. So we're going to say, okay, well, a is going to be equal to 2. Then it asks, well, what is the common ratio b value for this function? Well, b is represented by that common ratio, right? So here, if we kind of look at our y values, we know from 2 to 6, that's like multiplying by 3. From 6 to 3, we're multiplying by 3 again. From 18 to 54, we're actually multiplying by 3 again here. So because of that, we know that our b value is probably going to be 3, okay? Then it asks, okay, well, now that we have our a and b values, let's write an exponential function that models these values. So here, I'm going to use this basic equation, y is equal to a times b to the x power. I'm going to use green here. And I'm going to say, okay, well, my equation has to be 2 times, which is my a value, times 3, which is my b value, to the x power. So I know my y is equal to 2 times 3 to the x. I'm going to move that down here. And now it asks you to plot the function on the coordinate plane. I did this part already for you, but you're going to use Desmos to do it for you on your own as well. And then from there, you can use Desmos to figure out this last question. It's asking, well, when x is equal to 8, what will the value of y be? Well, we already have an equation, so if we wanted to do this, we could calculate for it. So if I know that my x is equal to 8, then my y is going to be 2 times 3 to the 8th. And if I did this out by hand, I could see that, well, I'm multiplying 2 by whatever 3 to the 8th is. If you do that out on your calculator, you're going to get 6,561. And then if you multiply that by 2, you're going to be left with 13122. So 13,122. And that's going to be my y value. Another way you could have done it was you could have used Desmos and plugged in, well, x is equal to 8 with your graph, and where it intersects will be your y value. Moving on to the concept development, we're going to be talking about some transistors. So the important words you should have picked out in this was the number of transistors doubles approximately every 2 years. So you're thinking exponential, you're thinking of powers of 2. And so it asks, okay, well, you're going to answer these questions assuming that there's one transistor in 1965, okay? So that tells us that our 0 years from 1965, our x value when moving on to the concept development, we're going to be talking about transistors. So the most important lines in this paragraph were the number of transistors. Moving on to the concept development, we're going to be talking about transistors. The important words you should have picked out from this phrase is the number of transistors doubles approximately every 2 years. So this is when you're thinking exponentially, you're thinking powers of 2. The word doubles, right, every 2 years, those are all, you got to think 2. And then it asks to answer the following questions, assuming that there's one transistor in the circuit in 1965, okay? So if we're talking about 0 years from 1965, that's what we're talking about, is when our x value is 0, okay? So when we have 0 years since 1965, in other words, 1965, then we have one circuit. So my x value is 0 and my y value is 1. And that's what you see boxed up in red right there, 0, 1. That's our first point. So that's what we have to go off of. And so it's asking us, we need to make an equation. So we're going to say, okay, well, f of x is equal to, okay, well, I know it's power of 2. So let me try to figure this out using this first data point. So I know that if I have 2 to the 0th power, I'm going to get 1. So that works. But if I have 2 to the 1st power, I'm going to get 2. Because anything to the 1st power is going to equal itself, just like anything to the 0th power is going to equal 1 always. So as you can see, 2 to the 1st is not 1.4, it's 2. So we clearly did something wrong. So we're going to play around with these little numbers a little bit, and okay, well, it says it doubles every 2 years. So let's try dividing that exponential by 2. So instead of having just 2 to the x power, we're going to have 2 to the x divided by 2. So here we're going to double check some of our work. We know that if I have 2 to the 0th power, I'm going to get 1, because 0 divided by 2 is just 0, so you're still going to get 2 to the 0th, which is equal to 1. Then if you try 2 to the 1st over 2, you're going to end up using your calculator for this. It's actually 2 to the half power is actually another way of saying the square root of 2, but that is going to give you 1.4. And then here we're going to try again, and we're going to say, okay, let's do 2 to the 2nd power over 2. And then we're going to say, okay, well, 2 over 2 is just 1. So that's going to equal 2 to the 1st, which is equal to 2. And as you can see, all of these points are working out for us so far. So that's probably going to be our equation. So what you can do is I'm going to have you complete the table, and you're going to graph it. You're going to use Desmos to graph it, and then you're going to put like a little sketch. But the graph itself is actually already uploaded for you guys under your worked out solutions and notes for this chapter. Moving on to the next page, we're going to be using the same exponential function. F of x is equal to 2 to the x divided by 2 power, and we're comparing it with a polynomial function, g of x, which is equal to x squared plus 1. I've already put the y values in for you, and we're being asked, well, as x increases, which function is greater? If you look at these numbers, we're going to get g of x, because these numbers for this function are growing faster and they're bigger. And now we kind of have to graph our function, which is our 6th question. So let's go to question 6 before we go to question 5. So here we're graphing both f of x and g of x on this 12 to 12 window. And here I did a rough sketch of both. And what I want you guys to be aware of is if I go to Desmos here, I graphed it. And if you're zoomed out, you might not be able to tell that they touch, but they actually do. So we got to zoom in to this little interval right here. So from 0 to 0.3698, we know that f of x, which is my blue function, is greater than my g of x, which is my purple function. See how the f of x is on top, has bigger values than g of x during that interval? So here, I know that no, it won't always be greater, because when x is 0 to 0.3698, f of x is bigger than g of x. Okay, so that's what I did here. I just drew a little intercept, and I put that in red, and it asks again, well, which function is greater? We're still going to say g of x, because even though there's that small little part where f of x is greater than g of x, the remainder of the function is greater than f of x for the entire rest of the function. Moving on to the entry ticket for lesson 2, we're going to be looking at 2 other exponential functions. So the first one, we're going to call it a of x. It's asking for when you get paid an initial amount of $10 and then you receive an amount in dollars each day that is equal to the day number cubed. So in other words, you have $10 and then whatever that day, the number of the day that you have cubed, is your equation. So they give us an example. If on day 1, which is x is equal to 1, we'd have 10 plus 1 to the third. So this is our basic equation, and I filled out the rest of the table for you. This is our second function, and this is when you're getting an initial amount of $10, and then it's compounded by an interest rate of 30% per day. You might have recognized like an equation from a while ago that was like P initial times 1 plus the rate over n to the n times t power. That you might have heard of that compound interest equation. But here we're just going to use the model that they gave us. So our general equation is 10 times 1 plus the rate to the xth power. So the rate is just 0.3. So in other words, it's just 1 plus 0.3, which is just 1.3. So I have the boxed equation up right here in green. And I filled out those values for you.
To the next page, we're going to be comparing a of x and b of x. Just the table here is color-coded the same way as we just had color-coded a in purple, b in green. Our first question is, well, estimate where a overtakes b, okay? So we're going to graph both of these functions. So they're in Desmos right here. And if you go home, it doesn't really give you that great of a view. So you kind of have to fix these windows a little bit. Well, a overtakes b at this point. But the one thing I need you to be careful of, because you at this point probably got confused, well, a takes over b, but that doesn't make any sense because b is still the greater function. Well, good thinking, because if you scroll up a little bit, you keep scrolling, So if you look here, from 0 to 1.836, we know that b is bigger and a is smaller. So a overtakes b at that point. But if you zoom out here, and I'm going to just be careful what you're looking at here, okay? See those intersections? That's my first intersection I just spoke about. And if I make my windows larger, my y value is larger, I'm going to squeeze this this y-axis. I'm going to keep squeezing. I'm going to try to see if a overtakes. And if you kind of look here, it kind of looks like there's going to be another intersection here. So right here, that's my next intersection. After this intersection, I'm going to zoom in on this little intersection. Here, we see that A, after we reach that point, A is smaller and B is larger again. So as you can see, from that point of first intersection, right here, to this point, A is larger. So that's where it overtakes B, from 1.8 to approximately 30.1. It asks, well, does the graph of the function confirm your conclusion? Yes, it does. And then it asks, well, for what range of values was A bigger than B? Well, we just talked about that. For the range that the value of A was less than B, well, that's the opposite, right? So when x from 0 to 1.8, you see that your B value is greater. Then we determined that that's when A starts increasing. And then after all this scrolling to find our next intersection, we saw that B surpasses A again at this exact point. So when x is equal to any number greater than 30.187, that's when B starts increasing again. And it's greater than A. And that continues for the rest of the function. That's why I put infinity. So 0 to 1.8 and then 30.1 to infinity. That's when B is greater than A. Moving on. What option would you choose? Well, I would choose B of x because it's more money in the long run. And it's asking, well, what conjecture can we make about these polynomial functions versus exponential? Polynomial versus exponential. Well, exponential will always be bigger eventually. For part 2, we're going to be doing very similar things, but I'm going to actually ask you guys to do this part on your own, and we're going to be kind of playing with some parameters and estimating what happens depending on what we do and how we scale A and B values. Okay, so we're actually going to do this part in class together and answer those 3 questions.